Hello and Assalamualaikum. So in this video, I would like to present my assignment for Transform Circuit Analysis subject, and the code is BEV20203. So first and foremost, my name is Amirul bin Zuhaili and my matrix number is DE190203. Alright, so the title is Fourier Series Analysis and its Application. Right, so I will cover the manual calculation. Right, so as you can see, this is the manual calculation. So the first thing that we need to do is we have to determine what type of graph we want to use, and my team and I has decided to use square wave as our graph. So we put the amplitude as 30 volts, and the one complete cycle is equal to 2 seconds, and the omega is pi, and the frequency is 0.5 hertz. Okay, so after you have all the information, you can simply find the A node, the AN, and also BN. Alright, so this is the formula for A node, as you can see, and you just need to insert the value for the time and the function of t, which is the amplitude. Alright, so for the integration, you have to insert the value of 0 to 1 second and 1 second to 2 seconds, and then you just need to integrate, and we'll get the answer is A node is equal to 0. And after that, you need to do for the AN, and this is the equation for AN, and you just need to insert the value of amplitude, the value of time, and do the integration for the 0 to 1 and 1 to 2 seconds, and calculate and do the integration, and the answer is AN equal to 0. So after that, you have to do the same thing for BN. Alright, so the difference between the BN and AN is AN is using cos while BN is using sine. So this is the formula for BN, and yes, it's very similar to AN. You just need to insert the value of amplitude, time, and do the integration, and you will after you reach this step, you need to look at your graph. Okay, so in this case, our graph is square wave and it is odd symmetry. Okay, so if we are using odd symmetry, then our n is going to be between 1, 3, and 5. Okay, so I have stated here. So if we try to use the n equal to 2, 4, and 6, we will get the answer BN is equal to 0, and we have to try that. Okay, so after we insert the value of n equal to 1, 3, and 5, we get the value. Actually, we just choose to use n equal to 1. So we insert the value of 1 here in the n, replace n with 1, and yes, we get the BN equal to 120 over n. Okay, so actually you don't need to replace the denominator n with 1, because we can just simply factorize it out and be in this form. Right, so this is the general formula for the square wave. Right, so we have, what we need to do is just substitute the value that we have obtained. So our A node is 0 and our AN is also 0, so that's why we don't put anything. And for BN, we have obtained this value, so we just need to replace. Okay, so this is our VS, and after that we jump to our circuit application. Alright, okay, so the first thing that you see in our circuit is all the value is in T domain, so we have to convert everything, all the value, to S domain. Right, so we have changed the value of resistor, for inductor, and also for the capacitor. Right, so this, as you can see at the middle branch, this is we consider it as a branch 1, and on the right is branch 2. And in order to simplify the circuit, we have to do the summation for resistor 2 and also the inductor 2. And for branch 1, we have to do the summation for inductor 1 and also the capacitor. So after we have all the information for the circuit, we can simply find the total impedance, the ZT. Right, so we do the summation for the branch 1. So you can see this is the formula. I think this is the basic formula, and then we do the summation for the Z2. Z2 is the total of resistor 2 plus inductor 2, and after that we have to do the Z3. We parallel the Z1 and Z2, and we will reach the answer this step. And after that we continue to find our Z total, our total impedance. So alright, at this step you couldn't solve it as we have n, which is n is we don't have the value for n, but we know that our voltage is, or our square wave is odd symmetry, so we just assume n is equal to 1. Then we just insert the value of 1, replace it n by 1, then our total impedance is 11 plus j 0.67, right? So after that, we know that for DC components, the n, the omega, and also the frequency is equal to 0. Okay, so anything that multiplied by 0 will get 0. So I just simply wrote that the Vs is equal to 0, but for AC component, I have convert from this form from polar form to the rectangular form, so that easy for us to make a calculation. And then after that, then by using the AC component, we just need to find the voltage at the branch. Okay, so we use the voltage divider. So as you can see, this circuit is already simplified, and this is the Z3, and the voltage divider is at the Z3, because we know that the voltage that came to branch 1 and also the branch 2 is same, as it is connected to the same node. So this is the formula of the voltage divider, and we just insert all the value, and after that we just need to assume that n is equal to 1. So just like this, we just do the calculation and press your calculator, then we'll get the answer, right? So the answer is this, is it? Wait. Alright, so this is the last value, for the final value for the voltage at the branch. So we know that the voltage at branch 1 and branch 2 is equal, as it is like I said, it is connected to the same node. So yes, for sure it will be the same. So after you have find that the voltage at the branch, you can we need to find the current at the total current for the whole circuit, right? So we are using the Ohm's law. So for I total, we just do the divide. Vs is divided by the total impedance, and yes, we have considered that DC component is the I will be 0, because we know that n is equal to 0. So for the alright, actually this is the AC components. Okay, so we replace the n equal to 1, and this is the equation. So we just put the value, and this is the answer in polar form, but I change it to the time domain, so we get like here, because you can see that there is t, so that's why it is called time domain. And after you have obtained the total current, you can we need to find the current at each branch. So first we look for the I1. So this is the equation, and we just put the value and replace n equal to 1, and we simply get the answer. And we'll do the same for the I2. Sorry, this is we'll find the I2 first, and then later we find the I1. Actually this is I1, but it should be correction here, right? So this is I1. So for I1, similar with the I2. We just use the same formula and replace n with 1 and you will get the answer. So this is the answer for I1. Right, so the last thing that we need to do is we want to find the power for the power absorbed at the branch 2. Actually, we can find any power at any branch. Maybe can be power at branch 1 or total power for the whole circuit, but we choose branch 2. So as we choose branch 2 as our reference, so the current should be at the branch 2 and the voltage should be the voltage at branch 2, which we can simply say the voltage at the node. Right, so for the VDC and IDC, we know that it is equal to 0 because we have calculated it just now, and we also need to know the degree for the voltage and also the current at the branch 2. So yes, we just need to replace all the value, insert all the value, and then just press the calculator and we'll get the answer is the power is 2.26 watt. Right. So all the calculation is just in flow. So, and I can say that the question is pretty well, is good, and we have done. So that's all from me, and for the simulation part will be covered by my friends in the next video. So thank you for watching.